我哋係咯，咁啊 Op 就啱啱去到而家搭9咁樣就完成咗佢個 session 啦。咁我哋而家去 move 翻去另外一個 session。Hello， Weiyuan。
Hey, thanks for having me.
Thank you. And I think the topic you'll be presenting is the live streaming with Google Cloud, right?
That's right. Yeah.
Yeah. And I can see you have your presentation ready.
Yep.
Are you ready to give your
I'm ready to
talk?
go. Yep.
Right. Good. That's good to hear. So I'll pass the time to you.
Awesome. Thanks. Right. So, good afternoon, guys. Thanks for joining us today. I've this topic that I've been working on over the last half a year. I'm really excited to be sharing with all of you on this wonderful afternoon. The topic itself is called live streaming with Google Cloud and why you should use the cloud for your application needs. But for the purpose of DevFest, I'm going to focus a lot more on the Google Cloud portion. Not so much about, I would say, maybe the fun part of live streaming, but we'll look at the live streaming part as more of a case study and why I wanted to create something that solved this problem and how you can actually use Google Cloud to solve for your own application needs as well. So my name is Weiyuan. I'm a Google developer expert with Google Cloud. I'm also an organizer with this organization called Big O Development, where we look at developing people's careers. It's more of a not-for-profit organization. We operate around the Southeast Asia region. And this project was actually something we built for this organization to allow us to adapt, to this entire pandemic situation. All right, so let's get things started. So I want to start off my sharing with this slide. This is kind of the, I would say, for any newcomers who are coming into Google Cloud, you would be faced with essentially some of a representation of this screen, which is that there's so many tools in Google Cloud. Where exactly do I start with? What exactly do I use to build your own application? And the answer to that is that yes, it may be overwhelming, but you should choose the right tools to solve your problem. Different tools have different purposes. And it's the strength of Google Cloud or testament to Google Cloud as a cloud provider, which provides this host of many different tools in solving, distinct problems. So let's say, to give you an example, if I'm a startup, I'm looking at creating a POC, I just need a simple relational database, I should go for something like Cloud SQL. It supports Postgres, it supports MySQL. If I want to create an application that supports millions of customers, I should go for something that's more scalable, like Cloud Spanner. So you can see very similar purposes, but very distinct tools in terms of meeting different purposes. All right. So as mentioned, it can be very overwhelming. There's so many things you can use. Like you go to a Cloud Console, the left toolbar, there's so many tools. Just choose the one that you need to build for your own application needs. Focus on your problem and understand what exactly you need to solve to pick the right tools. One bonus I like to add on, as someone who has used Google Cloud for some time now, if you're already using Google Workspace, I think it's something that ties in really well with using Google Cloud. If you have to look at using a third-party application, like some CI/CD tool, usually what happens is that in your own organization, you need to create your accounts or get your employees to create some accounts over there, and then find out some way to connect these two different applications from two different platforms. But if you're using Google Workspace, let's say for your company account that doesn't end with a gmail.com, but you're using the Gmail client, essentially what it also means is that those same accounts works in the Google Cloud as well, because they're within one single ecosystem. So that's what makes using Google Cloud really, really interesting over here. You're under one single umbrella. It makes things a lot easier for you to integrate. Okay, so enough about the the introductory part for this. I want to jump into the case study, to introduce to you, why we started off with this. What's our problem statement? Why do we want to solve for this, and how do we solve it? So going into the problem statement, right? So I think this is something, is occurred around the whole world. It's a global pandemic event where I think different countries or most countries, they don't encourage you to do any more physical events. And that's the same for where I'm located at, in Singapore. So we are instructed that, for our own meetup events, we should try to move things online, or in fact, we can only do it online. So this means, some form of live streaming event, if we are looking at moving our meetup events online. All right. So But the issue is that as we look into a live streaming solution, in terms of meeting our own needs, we find that we have three different problems that we want to solve with this live streaming solution. Firstly, we wanted something that's easy to use. Think about it as a physical event where you go to a venue, you bring your laptop, you plug in HDMI wire as a guest for that event. It should be something similar that is easy to use like that. If I can just jump in and be able to know how to use it right away without having to jump through a lot of hoops, in order to get started. Similarly, as a host, it should be easy for me to use this as well. Like not having to jump through a lot of hoops to understand how to use this live streaming application. The second thing is that we wanted this to be affordable. So because we were self-funding our own activities, again, like mentioned, we are not for profit. So we wanted to make sure that we also choose a solution that doesn't allow us to break our bank, essentially take a lot of money out of our own pocket. So essentially, if there's something that is affordable enough for us to use through this entire duration, I think that's something that we wanted to have, this solution. Lastly, this is something that was a little bit more special. I think most live streaming solutions don't really have this problem, but we wanted to have a live streaming solution that allows us to stream to multiple locations or destinations, meaning something like Facebook page and YouTube page of one single group, and maybe we have like another three other partners we're working with, and they also want to stream to their LinkedIn page, Facebook page, YouTube page. We could essentially be streaming to, let's say, 10 destinations. So we wanted this solution to be able to fulfill this condition as well. So again, a very interesting restriction or condition, to our problem statement over here. So we started looking off, instead of just looking at building a solution right away, sane minds prevail. We wanted to look for a solution that's out there first and see if there's something that's already out there before looking at reinventing the wheel. So a very popular solution, dedicated streaming solutions like using Facebook, YouTube, Twitch. These are companies that already provided some form of solution for us to be able to use them for live streaming purposes. But as we examine the solutions, we find that they didn't really fit all the three criteria we put in. Just to show you over here, affordable, definitely, it's free to use. Easy to use, kind of like you have to get used to some of the more complicated controls inside their application, but once you're used to it, basically it's good to go. For your guests, maybe it'll be a little bit hard for them to pick up for the first instance. But the one big problem we had was that we can't stream to multiple locations or destinations because these are companies that provide the infrastructure for doing this live streaming. So it doesn't make sense for their business model to allow you to stream to, let's say, from Facebook to YouTube. This is essentially empowering a competitor who don't need to pay any money for their feed that's coming in. So it makes a lot of sense that they don't do that, but it also means we can't use them. Okay, so if we can't use dedicated solutions like this, what else can we look for? How about an open source solution like OBS Studio? And we did look into it. One big problem is that if you see that application on the left, it's a very complicated interface. I have friends who have used OBS Studio before. From my interviews with them, it seems like it's something that would take up some time to get a handle on. You need to get some working experience with it before you get used to how you use it. Though it was affordable and they do support the option of streaming to multiple destinations, we were not convinced that this was an easy solution for us to be able to easily propagate to both the host as well as the guest. So making it not a very suitable solution. Okay, so we have looked at free solutions out there that are supported by different companies like Facebook or YouTube. You have open source solutions like OBS Studio, and we find that these are not fitting our problem statement over here. What else can we look at? So we started to think, okay, affordable doesn't mean free. Why not we pay a little bit of money and see if we can, find a cheap solution that can get us to meet, all of these problem statements we've put forth. And that's why we end up with StreamYard, which is actually coincidentally what is being used for the live stream today. And looking to it, so you can see on the infographic on the left, they do support that one single problem statement that the one single restriction that we wanted to solve, which is streaming to multiple destinations. And given the interface is definitely very easy to use as well. As a host or as a guest, you just have a few controls here and there. It's very intuitive, very easy for you to get started. And as we analyze it even more, This is where the interesting part comes in, where money talks. If you want to be able to stream to more destinations, like just now I mentioned, we wanted to see if we can explore being able to stream to 10 different destinations, for example. It actually means that you have this counterbalance against the affordability, where you have to subscribe at an even higher tier just to be able to get the ability to stream to more locations, which means that it becomes less affordable. So you have this contradiction. Not exactly the best, because the highest tier that allows us to stream to, I believe, 8 destinations today is 50 USD per month. So kind of expensive. Not the most affordable for a not-for-profit organization. We have to look at paying like 600, almost 600 USD a year. Yeah, like I said, not a very affordable choice for us to go with, right? So we came to a dilemma where we can't really find a solution out there to fix our problems. But then we started thinking, some of us, we know how to use Google Cloud. Should we use Google Cloud to build something? Doesn't feel like something you should do as well. It's like building an entire StreamYard service and then selling it as a startup. Definitely, we don't have the manpower to do that as well. But what if we just aim for the solution in the middle? What if we build some sort of wrapper that allows us to wrap around more of this difference, just 3 solutions, and then just provide the additional functionality that we need to solve our entire problem statement? So that's where we went with. So we went with StreamYard. Okay, we decided, why not add something on top of StreamYard to allow us to be able to achieve more that we want within our entire problem statement. So earlier on, we established that you can use StreamYard to stream to multiple destinations. And it doesn't just mean that you can stream to like Facebook, YouTube, LinkedIn, Twitch. You can also stream to your own custom RTMP server. And by using, in theory, by using this custom RTMP server, I could just use it to multiplex to even more destinations that I want to, allowing us to meet all of our different conditions that we put in earlier, that we can keep ourselves at a lower and affordable tier, of using StreamYard. And also, of course, we're still using StreamYard, so it's still easy to use. But then we can now stream to multiple destinations to meet our own goals. Okay. But going further in this, we decided, as engineers, let's do it with a proper engineering mindset. In that we don't want to vendor lock ourselves. So let's not put in the assumption that the source is always StreamYard. It could be from Zoom, it could be from Google Meet. The assumption we'll make here is that the custom RTMP stream can be from any different server, as long as we have this Google Cloud server or application that allows us to receive from the source and then disseminate it to a destination. That's all we need to get it working. Okay. So we went with this in mind and decided, okay, let's get started to build the application. Now, the interesting part, how do we do it? So I'm going to bring you through the journey of us doing this by bringing you through an architecture diagram, as well as deep diving into certain portions to give you a better appreciation of what tools we're using. So let's start off with the black box. This is the simplified architecture diagram for solving, how do we get this live streaming to multiple destinations, and then it has to be easy to use and affordable or cheap to use, right? So we have a black box. We know that we need to have this RTMP application that allow us to multiplex to multiple destinations. Okay, let's take away that black box and start implementing, or rather start putting labels on it. Well, if we're talking about an application we are hosting, we need to start thinking about, in the terms of the cloud provider and what tools they provide. We need to start thinking about, what type of tools we want to use as well. Do you want to go with serverless? Do you want to go with functions as a service or infrastructure as a service? And functions as a service is considered as a subset of serverless as well. So each one of these have distinct purposes that solve, I would say, different problems. While there's definitely overlapping problems that they can solve together, you should definitely examine and find out the best solution that suit your needs, especially for the long term. So if I can pull out this, the comparison over here, you can see that, there are certain advantages of using serverless, like it's easier to configure, easier to scale and maintain, but it's very hard for you to customize certain, additional or special requirements you need on top of it. Is the counter, like for IaaS, infrastructure as a service, referring to things like compute engine in Google Cloud, where you get your own virtual machine? It's in fact the opposite, where it's easier for you to customize because you have the actual virtual machine to play with. But it might be harder for you to maintain, as compared to serverless, where you can just scale with a click of a button or changing just a single number on the web interface, for example. So these are the different pros and cons of using, this different choice of different tools in Google Cloud. And what we decided for is that we went with IaaS, infrastructure as a service, or to be more precise, going with compute engine. And it's a very unique choice here, or rather, the decision of going with that was because for the RTMP stream, RTMP itself is only supported on the networking solutions for the compute engine, and it's not supported for serverless solutions like Cloud Run, App Engine, and Cloud Functions. So in this distinct case, we don't actually have a choice, but we know that we could use compute engine to solve our problem. Hence, we went with that. So let's replace this black box with compute engine. Okay, so you have compute engine over here. We have a virtual machine that we know that we need to create for this application. So as we started getting this built, we started thinking, okay, what should we need? What should we build within this application to achieve that multiplexing? All right. Okay, so we found out that there was a Nginx server that we can use with a custom RTMP module that allows us to be able to implement this multiplexing logic, right? So just to jump into the configuration very quickly. Now, I'm not going to show the entirety of the code, but more to allow you to see, what's going on within that server. So you have a Nginx configuration over here. You can see on the left-hand side. A big portion of this, I'll talk about it a bit later. But the important part over here is at line 20 to line 22. Now, just to mention, this is not regular Nginx configuration. This is actually a handlebars template that I'm using over here. So I'm running it through some templating engine later on to populate all the values I'm putting in. Okay, where I'll be putting in all the values of all the RTMP destinations that I will be pushing towards. So you can see over here, each one of these is a RTMP push URL. Okay, so once they're configured, it's deployed, it should be able to have all those different statements indicating where it should supposed to be pushed to, allowing me to achieve that multiplexing effect. I also have some specialized implementations over here. You have a node server. Again, I'll explain about this later on. It's not really related to the multiplexing. And we have an S tunnel, which is TLS proxy, allowing us to connect, our stream, our multiplexing stream or proxy stream to secure sources. So similar to HTTP, HTTPS, you have RTMP and you have RTMPS. So essentially, we have to use something at S tunnel that allows us to support these secure connections. All right, so let's go back to our initial virtual machine over here. All right, so we know that we're going to be implementing this solution over here. Okay, and we also need to make sure that we take care of certain networking restrictions that we want to put on top of this, because like I said just now, we have a node server. It could be running on something as mundane as port 3000 or 8080, but we don't want to expose that to be hit publicly. So you should definitely use cloud networking to set in things like allowing only the port 1935 to be exposed for your RTMP server to be able to access. Okay, so allowing us to only have that establishing of that stream and then doing that multiplexing. While internally, you can still expose those ports to be used internally within your own application. All right, so definitely look at putting in cloud network over here. Okay, and then some of you might be thinking over here right now. Okay, so going back to the earlier restrictions, we talk about multiple destinations, we talk about affordability. Affordability, we can talk about it at the end of this whole thing. But then there's one thing we talked about, which is easy to use. How is it easy to use if I need to go in, provision a VM, install Nginx, put in a configuration, run the handlebars template, blah, blah, blah. There's so many steps. How is it easy for me to set up? How do I deploy this in a very easy way? Well, the solution to that, some of you might be thinking, what if we go for something like containerization? For serverless solutions, you have those options in Cloud Run or App Engine custom runtime where you can provide a Docker image. But to be food, in Compute Engine, there is a choice for you to go with that option as well. If you choose for this thing called Container Optimized OS, so you can see I also include at the bottom left over here. If you choose the Container Optimized OS option for your virtual machine, it allows you to be able to set in your own configuration for putting in your own Docker image to set up as a container in the application and run it as part of your solution. so you don't have to go through the whole process of setting things up manually. All right, so the configuration, as you can see, something like this. Within the virtual machine, you put in the configuration for your Docker image and also indicate things like the options on how you want to run this container. Okay, so once you have built your image, make sure that you have this image accessible to your virtual machine and you can host it there. Okay, but then the question here now you might be asking, which is, where exactly do I save this then? I can build the image locally in my machine. Should I push this to something like Docker Hub? That's a popular solution. My answer is yes, you can go with Docker Hub, and you don't need to do any additional steps if this image is okay to be exposed to the public. But in the case of if you're building this for your company, usually you have proprietary code that you don't want to expose. So your images should be private, and hence you should use something like a private repository in Docker Hub, which means that you need to go on a paid subscription. Okay, but I can tell you an even better choice, than using, let's say, third-party solutions. Why not just continue using Google Cloud's ecosystem? You can see over here that the domain over here is gcr.io. This is actually pointing to within Google's own ecosystem, pointing towards their own container registry, right? So if I pull out here, you can see that I've included one more new term over here. At the bottom is container registry. It can be used to serve as your own image registry. Every time you build a new Docker image, you save it in this registry and you only allow the access within your own project. Okay, we'll talk about the access control a bit later. But essentially, what this means is that you could essentially have this entire workload or your entire project, as well as team members associated to a project, to be able to access this image and use it for this deployment. Okay, thus allowing you to secure, if you have secure like your proprietary code within your images. Okay, as we reach this stage, some of you now might be asking, all right, so I need to build the image, I need to push this image. But again, is this a manual process for me to build that Docker image and push it up? Again, we can go around this by implementing something like a CI/CD pipeline. So this is again something that that you guys might really know, in terms of setting up your own DevOps infrastructure for your company. And there is a very good alternative. There are many good alternatives out there. But if you're using Google Cloud, again, I'll go with using Google Cloud's own ecosystem, which is to go with something like Cloud Build. I just want to caution at this point that I'm saying a lot of Google Cloud. I'm not trying to sell for Google Cloud, but the idea is that when you're using everything within the same ecosystem, it's a lot easier for you to integrate, where you don't have to go through doing these third-party integrations where you have to pull out things like your own private key for accessing, your let's say for your CI/CD pipeline to be able to access, let's say, your private image registry, Docker image registry somewhere else. You don't have to get that private key installed in a pipeline and do all those additional things. Later, I'll show you how, where it's actually very easy for you to get started with setting up everything within here if you're using the same ecosystem, especially, in this case for CI/CD pipeline using Cloud Build. So Cloud Build in the Google Cloud is a very, very useful tool for you to build your own CI/CD pipelines, right? So I'm going to show you the representation of a configuration and how it looks like in the output. Configuration over here, you can see that this is essentially a YAML file that you can submit within your code repository itself to indicate what you want the pipeline to run. And essentially, you can put in the steps of what you want the Cloud Build to process. So over here, you can see that there are two different stages or two steps. One of it being to build or install some node modules. And the second step is to use that node modules and construct a Docker image from there. So a very simplified CI/CD pipeline where you're looking at building a Docker image with some node application in there. Okay. On the right side over here, this is essentially the visual representation of it in Google Cloud's web console. So it's very useful where you can see that there's these three checkboxes over here. So the bottom two checkboxes, you can click into them and see this individual two steps over here, the logs that are produced as you run through a pipeline. So this allows you to debug, if let's say one of these stages fail and the whole pipeline is failed, they cannot proceed with, let's say, pushing the Docker image. You can look into it and understand, what has gone wrong. So, and also one very interesting thing here is that the Cloud Build configuration is very, very versatile. You can use it not only in this series dependencies as you see over here, like of course, building a Docker image has a dependency on installing the node modules in the environment first. But if you have additional steps like running like some of your tests, unit tests, let's say if this is a monolithic application, you have front end unit tests, you have back end unit tests, you could just run both of them in parallel. You don't have to run them series one after another. And this allows you to build your own directed graph of both series and parallel dependencies so that you can ensure that your pipeline completes as fast as possible, allowing your engineers to deploy as fast as possible. All right. So this is for cloud build. So next thing, another thing that I want to introduce to you is if we want to make this deployment much easier, one other thing you might be asking about is, what about access control? Not access control. What about configurations and secrets? How do I exactly put this configuration and deploy it as part of my application without having to manually inject it, without having to, let's say, manually put it in my Docker images or build it as part of my Docker images over here, which is a security flaw. You don't really want to do that. It's hard to deprecate secrets, especially within your Docker images. Or injecting a CI/CD pipeline again, maybe not the best choice. So, is there any way we can look at in terms of solving this? All right. So managing secrets in a Google Cloud's environment is a very interesting tool that they released last year in terms of solving this, which is to use Secret Manager. So you can see over here, I've included another new tool, which is called Secret Manager. Okay, so it consists of, rather you can use it for saving your secrets, saving configurations that you want to implement on top of a server. When you deploy, you can just grab the secrets and configuration and use it. Let's say for, I think very popular choice for applications is to use, let's say, the .env module to be able to set up, your environment variables and use those environment variables to run your application. So you can definitely use something like Secret Manager to populate your environment variables and get the application started. Another popular way is you could just use the JavaScript SDK and just hit Secret Manager directly and get those values on the go. So you don't even need to restart the application sometimes if you change the secrets on the fly. All right, so just to show you what Secret Manager looks like in the web console, it goes something like this. If you have used it across multiple iterations, you definitely get like multiple versions of a secret. One important thing is it allows you not only to be able to manage your secrets, as part of Secret Manager, you can also do some version control on it. So let's say if you have this application that serves multiple clients, you're just replicating the code base across. Maybe an older client that refused the update could be on version 5 of the secret. So you can keep that version with the status, you can keep it not as destroyed, but before you destroy it, just leave it open and allow them to continue using that older secret that you want to deprecate. Until they leave your service, then maybe you can destroy it entirely to completely remove it, scrub it away, and prevent any security issues coming in the future. And then for your most latest applications, you can just use the latest version, in this case, version 10. But again, don't let this number fool you. You don't have to. Some of you might be thinking, this might be a bit of a hassle to put in my application. Every time I update my secrets, does it mean I need to go to my web application, for example, change the number, and then every time I change the secret, now I need to change the number again? Don't be fooled by that. There is a layers you can use for the SDK where you can just put in the term latest, where it will replace, or rather what you will do is always pull the latest value or the latest version of that secret into your application. So you don't have to hard code the version number if you know that your current code base should always push or pull for the latest version. Okay, so we have talked about how to set up this application very, very easily. We have looked at splitting out our configuration for our application, putting in Secrets Manager. We have looked at reducing the manual steps by building that Docker image and then allowing us to construct that Docker image from a CI/CD pipeline. So this CI/CD pipeline can be triggered from something as simple as maybe, let's say, a commit to GitHub or Bitbucket, and can use that to trigger the pipeline to build this entire Docker image. Now we have made the amount of instructions as little as possible, but some of you might still see certain problems over there, which is, now how do I ensure access control is done properly? If my Nginx server over here can access the configuration and secrets over here, doesn't it mean any virtual machine or even any computer, that's connected to the internet can get these values, how do I secure this access? So I can answer the question by another tool over here, which we need to use something like Cloud IAM, identity and access management. So you need to configure this properly to allow you to ensure that certain tools can only be accessed by certain instruments within your application. Okay, so let me demonstrate what exactly does this mean. So in this case, let's say you have some form of account. I'll talk about this account later. You have some form of account that you want to assign permissions to. So what you'll do is you indicate those accounts within the IAM menu, and then you also indicate the role, a role which is essentially a group of permissions that you want to assign to this account, and then basically you assign that role directly to the user account. Okay, so this account, this is not a user account, but this can be a user account. This account can be either a user account or a service account. A user account is essentially, actual human or account that's owned by a human like you and me. And a service account is essentially a machine account, an account that you bind to one of your workloads and let them be able to hold, certain roles to be able to access, roles in this case, ROIES, where you can have the roles and permissions to be able to access a certain service. So in this case, I could, do something as simple as allowing Cloud Build to be able to access Secret Manager, or I can allow my virtual machine to be able to access Secret Manager, to be able to perform what we saw earlier on, which is just allowing this virtual machine to access Secret Manager. Okay, so by doing this, what it means here is that I can securely ensure that only the service account in my virtual machine can talk to Secret Manager and take those secrets, that I want to expose. And only maybe myself as the admin, I also give myself the rights to talk to Secret Manager. Maybe for my other colleagues, some of them can have restricted read access, some of them can have write access as well. But for the rest who shouldn't be able to see, all these different secrets, they shouldn't be able to touch it. Even if they are working on those applications, they might not have access to these production secrets. And the really cool thing over here is that you can separate out the access, for different tools where, let's say for the developers that are working on this application, they're not supposed to have this production access to the secrets, but they're supposed to have access to being able to trigger the pipeline and actually use the image to be able to deploy to, let's say, a development server. They can still be able to see this Docker, this image registry, be able to see the Docker images that are built as part of your artifacts from a CI/CD pipeline. Okay, so they only have access to all these new builds that you build for your Docker image in the image registry, but not the secrets that are injected upon deployment, allowing your setup between your infrastructure as well as your employees to be a lot more versatile, because you can have a very secure development environment, you can have a secure staging environment where these employees can see the secrets, but they are not exposed to things like production level secrets, while they can still work on the applications without being disrupted, without being impeded to do their duties. Right, so really, really interesting in terms of making sure you set in in fact, I would say it's very crucial for you to set in the correct access control for your entire application to make sure that you don't inevitably expose your application for bad actors to attack your service. Okay, so we have talked about access control. Okay, how about making this a more robust application? If we're talking about creating this application, now at this stage, I want to make this a production grade application, but I can't call it a actual production grade application if we don't think about contingencies. There has been incidents where these different solutions on the right over here has gone down, like Facebook. There are times where it's gone down. YouTube has also had certain hours of downtime, at certain years as well. And it's inevitable that sometimes you are a bit unlucky. You may hit the period where you are live streaming and maybe the site goes down. You have no choice but to cancel your stream. But we don't want to disrupt the flow if we are streaming to multiple destinations and maybe some of these solutions has gone down. We want to make sure that we have some sort of backup process. So why not add something like cloud storage, as you see on this bottom right over here? Use cloud storage, as an object storage to allow you to back up video files, so that when I do my streams, as I finish my streams, why not create a MP4 file and then have a automation to be able to save that file to my bucket, so that after the end of my stream, if I need to, be able to restore use this MP4 file and upload it as VOD on any of these other platforms, I can do that. I have the option to do that. Or if I want to be able to edit this footage, maybe create highlights from it, you can do that as well. So we added in this additional implementation, giving us the flexibility as well as the contingency process to make this application even more robust. And this is essentially what we did. So this is the earlier what I show you, the Nginx application, as well as the Node application that I haven't really talked about yet. You can see over here on line 18, not line 18, the line 15 over here, you can see over here that once the stream is done, I wrote a script to be able to allow myself to convert and save the file into a MP4 file, and then trigger a process on my Node server where it will upload this file to my own cloud bucket. So allowing myself to be able to save these files into my storage. And after that, you should be able to visit your own storage bucket. And as any MP4 links out there, once you click it, you should be able to get it loading on a browser and playing like a regular MP4 file. So you can download it at this point, do whatever you want with it. All right. So thus proving that we can actually use this as implement Google Cloud's tools, right, as a backup process for this application as well. All right, so it has been a very long journey. We've added in so many different tools, but some of you might be again asking another question. Earlier on we talked about easy to set up, and we say, let's put in Docker image. But now I have so many different tools to set up. Some of you might be disputing the entire setup, this infrastructure again. Like, how is this something that's easy to set up? And I would agree. As I reach this point, I realized I might have created or implemented way too many things. I need to start thinking about how can I scale this? How can I be able to scale up my own experience of deploying this application? Because I'm not live streaming every day. I want to be able to bring down this application and reliably bring it back up again. So we decided to start, investing our time into another solution for helping us, which is to use infrastructure as code. Infrastructure as code essentially is to represent your infrastructure as code or configuration, and allowing you to set up your entire application or infrastructure usually with a single click of a button or maybe a few clicks. One very popular solution some of you might be aware of is Terraform. But in the case of Google Cloud, again, another recommendation I would have for you is that you can go for a tool which is called Deployment Manager. It has more direct support for a lot of the tools that you see over here in our application. So you can use Deployment Manager to automate the entire setup of your application needs. Okay, so we're able to do that by setting in things like the configuration, allowing us to be able to set in things like, for our RTMP server, for the virtual machine, what's our configuration. Like let's see over here, like the container type, I'm using a smallest one, F1 micro. At a certain time period, we realize when our demand is higher, we actually upgrade this to the next tier instead. And then you can see over here, there's an initialization shell script. So there are certain parts of a process like assigning permissions to our service accounts to give them permissions to be able to access, let's say, the secret manager. This is not something that you can enable very easily in Deployment Manager. So we decided to go with just shell script that we can invoke to directly assign these permissions. Since this is kind of like a one-time process, it doesn't cost anything. Even if you bring down the infrastructure later on, we don't really need to bring this down because it doesn't cost anything to set those configurations in, right? So this allows us to reduce the entire deployment process to one shell script where I just run it. I'll bring up all my deployment manager configurations, and voila, everything is done. The application is up, within just, let's say, 2 to 5 minutes. Of course, you still need to wait for some time for the virtual machine to be spun up, the application to be deployed, but the manual steps are very much limited to what you need to do. Like in my case, mostly what I need to do is just find, let's say, my billing ID, and then essentially plug it into this shell script and get it running. Just with one enter of enter button, and essentially a shell script will run. It will do the deployment manager configuration, and my whole application is up, allowing us to achieve our initial purpose of being easy to set up. As a host, I should be able to put this application up very easily. All right. So we have the entire solution over here. This is exactly all the tools I'm using. I'm counting the bottom over here. We are using 9 different tools. And this is our current solution in allowing us to be able to multiplex to multiple destinations. And you can actually see over here that we actually did more than what we required. But we did that because we wanted to solve more than just creating an application. We wanted to look at more of the engineering principles and building a application that allows us to better set it up more easily, allowing us to perhaps have contingency processes, so allowing us to do more than what is like just a simple hobby project, but building a actual production grade application, right? So just to prove to you that it works, I mean, okay, this is more visual proof of one of the live streams where we were very excited that it's finally working, and we managed to get this streaming to 5 different servers at once. You can see over here, there's YouTube. This one is also YouTube, and this 2 over here is actually passing over to Facebook. All right, so 5 different streams happening at once, allowing us to test and this POC that okay, yeah, it finally works. It allows us to multiplex to multiple destinations. Okay, and also on the billing side, just to mention that because we talked about this being affordable, I do have daily costs running every single day. That's around I think this is like 2 to 3 cents a day, and but it's very low because it's just a development machine that's running every day that I actually turn off, so you just pay a little bit of money. So every time I need it, I just turn it on. Of course, you can see over here that at the start development cost is a little bit more higher. But we managed to reduce it at the end where we work out all the kinks and find out that okay, we can just set it up, let's say 1 hour before the live stream and bring it down 1 hour after the live stream. So when you limit it down, compute engine was actually our bottleneck with the highest cost. But as we brought it down, you can see over here that in the half a year time period, we only spent around $15 HDD, USD. And this is definitely a lot more cheaper than the additional 25 USD per month, in terms of having to upgrade that subscription. So definitely a lot more affordable. But one advice I would say for you is that actually, okay, maybe also to mention one thing, I purposely didn't mention the credits over here. So this is actually excluding credits. If I included the credits that I receive as a developer, this is actually for free. Like I didn't pay a single cent over the last, I would say, half a year, because the cost is quite low. And also one thing I would say is that do take note of your free tiers. You can also see that things like Cloud Build, there's actually a free tier of the amount of minutes you can use for a CI/CD pipeline. So if you have a very simple hobby project or a POC, you should go for something like that first. Take note of the free quota so you don't exceed it and pay some money. But even then, it's usually the cost is very low. So do take note of the free quotas and how much quota you have. Okay, so we have gone through a plethora of many different tools. I hope I've been able to motivate you in terms of showing that you can plug and play many different configurations and solutions in Google Cloud for your own production application, for your own needs. But there's, the sky's the limit. There's always more that we can do. We've been thinking about things like if this is really a good production application, you want to do with things like telemetry. So using cloud monitoring for monitoring your metrics, doing things like alerting and functionality. Maybe we can improve this further. We have that contingency MP4 file. Why not use that as part of our functionality as well, where we can convert it to an MP3 file, use the speech to text API, create subtitles, use it, upload to our VOD. That's also some option that we can go with. So the sky's the limit. You can see what you want to build and find out what you can use Google Cloud to build it with. Okay, so this is where I think the interesting part of now that I've introduced to you, if you're interested, where should you start? So just to give you a few pointers on what you can use. Okay, so of course, when physical events are still about, you could join physical events. If physical events come back in the future, definitely I would encourage you to go for those when it's safe. Okay, but in the current situation, if let's say that if it's not a safe situation for you, then you should go for the online events. So here are some of the links that you can go to in terms of being able to participate in the online webinars, getting to understand more about Google Cloud. All right, so cloud.google.com events and Cloud on Air with google.com. Okay, I'm almost reaching the end. So, okay, this one is also another important thing. As a student and also before becoming a GDE, I actually use a lot of quick labs for me to learn how to use Google Cloud. because the primary thing is that it's not just a sandbox environment or not a fake environment where you just use Google Cloud, and sometimes like when you see all those practice environments from other tools, it's not exactly real. They just provision some fake buttons for you to press. But in the case of Quick Labs, the labs where you use when you do the quest, the labs are actually giving you a proper Google Cloud account. You're actually using it for real. And as you go through a lab, you actually get that sense of appreciation of, okay, this is the actual tool I'm using. Okay, this is the problem I'll actually face if I use it later on in my own work, right? So this is something that I would very much recommend in terms of getting to know Google Cloud better. But one tip I have is you should follow their. Okay, so I'm not encouraged by them to do this. Like I don't have any ties to Quick Labs. I'm encouraging you to follow their Twitter account because they do share some let's say the codes or game labs from time to time where the labs are for free, so you don't need to pay a single cent to learn from Quick Labs. So a very good tip is actually follow their Twitter account to whenever these game codes are being released, you can actually follow them. Again, take note of your free quotas. The quotas are free there perpetually. It should refresh every month, so you can just use them. Like as a student, I use App Engine to host because it's free for 28 hours a month. So I hosted this application for free, because 28 hours free per day for one whole month. So I was able to host my own website using App Engine standard for free for 24 hours every single day. Okay, it's using the smallest instance. But I mean, at the lowest tier, maybe you're just looking at just creating your own hobby project or your own personal web application. So, I mean, the smallest tier usually doesn't hurt too much when you only have a few users. Okay, so I've reached the, this is our reference. I'll share this later on. And yeah, we've reached the end if there's any questions.
All right. So while we're waiting for others to raise their questions, I have kind of like personal questions regarding the presentation. But first, let me thank you for your insightful presentation. Yeah. So I noticed that you use a Compute Engine instance to host a Nginx server, right? And what if, let's say, if I want to containerize this workload into let's say to transfer it into a Kubernetes cluster environment, and what do you think? And how much work do I need to transform the whole architecture?
I think that's a very good question because it's okay. I think some organizations or groups do categorize Kubernetes as a IaaS solution, but I would say it's not exactly that. It's a bit higher in the sense that lesser configuration you need or less customization as compared to Compute Engine. But that's it. Given from the current, let's say if I'm moving from this over to Kubernetes, I would say we have done the optimizations to be able to do that because we have already containerized the application in that Docker image. Moving to Kubernetes, you just need to make sure, okay, let me get that Docker image, put it inside a deployment resource, make sure you configure the ingress properly to be able to point to that application. For running Kubernetes itself, I have confidence that it should be able to support RTMP, given that you do have control over cloud networking. So that one shouldn't be a problem. But that's it. We didn't go to that extent for Kubernetes using something like GKE because we didn't felt the need for going to that extent. Now, if I'm going with something like GKE, I would be thinking about more of, let's say, if I'm creating an application with multiple microservices, for example, where I'm managing multiple resources, multiple deployments in my entire application. But if I'm just looking at one single solution that I want to just bring up very quickly in one virtual machine, no less, because this simple process doesn't need a lot of virtual machines to be able to do that multiplexing. So with this simple process, I should just need one single virtual machine without having a cluster with a node pool to get everything up. But that's it. Yeah, for a different problem statement where you have the application that has much more demanding computational needs, much more services, for example, you should definitely go with something like Kubernetes. In fact, with a larger team to support the operation, I would definitely go with Kubernetes over Compute Engine any day. I mean, also from personal experience, I think it's a lot easier to configure, a lot easier to maintain as well.
Yeah, totally agree with you here. Yes. as you said, we're using the cloud, right? We are looking for like a scalable solution. So just asking for my need, because back in my work, in my work experience, there are lots of like clients or potential customers asking the same, like how do I set up a scalable streaming service, like some of that. So yeah, and we got a we got Angel that asked how about HLS Dash, other streaming formatting for streaming.
So I think this one, it's a bit of the reverse, which is you're looking at using Google Cloud, their service as a source. Maybe let's say you have the video file in cloud storage, and then you're looking at streaming it outwards. For me, okay, so I wouldn't say I have too much experience with it. Like I've worked with this company called Viki before. They have used a mix of different storage solutions, whether it be it within Google Cloud or other providers, which I shouldn't name here for this event. But yeah, the how about HRS Dash and Smooth Streaming Protocol for streaming? This one I'm not sure if I'm have the expertise enough to answer it, but I would say that it's likely supported, given that if you are going with a solution that's more towards IaaS, usually you have control over cloud networking. And when you have control over cloud networking, usually that's not a problem. I think the big problem is when you decide to, like, just now the question that was asked earlier in terms of what hosting solution you should use, and then you ask about compute engine and Kubernetes, right? The other side of the picture is, should I go with serverless? And serverless, one of the things is that one of the things I learned, right, as going through serverless, because I never met this problem before, which is that there's not a lot of specialized networking protocols that you can run on top of, like towards this solution. And I think, if I'm not wrong, I think socket connections was only introduced recently. If I'm not wrong, I think it should be like last year. And that's when I was looking into RTMP and trying to figure out, okay, can I use serverless for it? Because I mean, if I'm just doing a small project for my organization, we want to go with serverless to make it as easy to maintain as possible. But from there, I did learn that, okay, yeah, the if you're going with this serverless solutions, certain hosting solutions, you don't get to have those options. But for things like GKE, Compute Engine, definitely I would say that they should be supported.
Yep. And Angel also asked another questions about does GCP provide any encoding services like transmuxing and stuff like that, and also translating to HLS Dash smooth streaming services.
Okay, this one
yeah. I think I can answer it. Is that the answer is in short, no. You have to implement it yourself. Yeah. So if I'm wrong, you please feel free to correct me. Okay. And I know Azure and AWS offer some sort of like similar encoding services, but sadly GCP doesn't have offered this kind of service yet. So we will see if it will get implemented in the upcoming years. So Fungo just left a comment, and that it's just about packaging, can package to the MP4 to Dash, etc. So this is not really a question, but rather like a comment here. And can apply for like.
I think that maybe that's a reply to Angel's.
Yeah.
Triggered it.
I think so. Yeah. So it seems like we got no more questions here. So okay. So thank you, Weiyuan, for today's talk.
Thanks for having me. Yeah, that was really great. Yeah, thanks.
Yeah. Thank you.